Are single pivot bikes bad? Well, the short answer is no. But there's a lot more to it. And I like physics almost as much as I like mountain biking, so I'm going to break down what a single pivot is and why they might be considered a little bit outdated. So the main characteristics of a single pivot bike are a large singular identifiable pivot point, hence the name single pivot. But the key to differentiating a single pivot design from other suspension layouts is that there's going to be a solid connection between the rear axle and the pivot point on your chainstay, and also a solid connection between your rear axle and the point of contact in the suspension, aka your seat stays. So essentially, in a true single pivot bike, this rear triangle is all one piece, and it's going to move about that central pivot point all at the same time. So if you've ever read Pink Bike reviews and they talk about leverage curves, you might be thinking, well, what's the leverage curve of a single pivot bike? And that is flat. I mean, there's no curve. When they're talking about leverage, they're really talking about torque, and that is governed by the equation torque is equal to R times F times sine theta, which is a fancy way of just saying R times the perpendicular force, which really is just saying no matter what force acts on a certain point, to calculate the torque it's going to have at another point, you need the radius between the 2 points and the part of the force that is perpendicular, hence the sine theta. So applying that to our diagram here of a single pivot bike, poorly drawn, I do apologize, I'm not an artist, but basically you have your pivot point, you have your rear axle, and you have the point that the rear triangle acts on the suspension. So if we want to apply how much leverage this situation has in an uncompressed scenario, we can say the force is going to be just a straight vertical force at point B, and then the radius is going to be this distance here, which is labeled with X. And that's going to be the leverage that it has on the shock. So quick side note, talking about that same force moving to the second diagram, we're really kind of talking about a tangential force because we're talking about a rotating system, and essentially, let me just draw what I'm talking about here. So if we look at a big circle here, okay, we have the rotation point, we have that first radius. Okay, so that's this scenario where nothing's compressed, right? And so your vertical force here is going to be perpendicular to your radius. You don't have to do anything. You just take that force, multiply by radius, there's your torque. Okay, moving to the second diagram where we move everything up, we've essentially just rotated around the circle a little bit. So your second radius is going to be, I don't know, somewhere up here. So your R2, right? And so this is where the F sine theta comes into play because you took that exact same force. And so, okay, now we have a force going like that, right? The exact same force, well, not all of it is perpendicular to the radius. And so to calculate torque, you take F sine theta, so you have to draw the triangle, find right theta, multiply force times sine of that angle to get your part of the force that is perpendicular, aka in this case tangential, so you really just care about that part of the force. However, for simplicity here, let's just assume we have the exact same force, and the force is also rotated so that it's perfectly perpendicular with our system here, and so we don't have to do any of that weird math. So you can see then that if you have the exact same force down here, the exact same radius, because nothing's changed. X2 is the same as X1 because it's a solid system, right? There's no linkages, there's no breaks. So as it rotates, that distance doesn't change. So if you have the exact same force, the exact same radius, we're gonna have the same torque. But is that bad? Well, no, it's not bad, it's just simple. And sometimes simple is better. Some people swear by single pivot bikes because it's predictable, right? It doesn't have any weird feelings. It's gonna act exactly how the shock you put on it acts, and suspension has come a really long way, both air and coil. And so sometimes maximizing that suspension is still fine with a single pivot bike. And in fact, there's companies that are doing this today. And I'll put an example right here above my head of one, but it's not a bad system. And I'll talk in my next video, variations of this single pivot design are used on a lot of modern bikes, including a slight variation on this is used on my bike that I ride every day. But that's all for next video, where we're going to talk about the next iteration in rear suspension design, which is a linkage driven single pivot. So follow and stay tuned for that video coming out soon.